The skin may provide a potentially underutilized channel to receive information that we typically receive orally or visually. This could benefit important applications by providing an additional information channel or a mode of sensory substitution. With this motivation in mind, wearable haptic designers are integrating different modes of touch sensation to wearable sleeves and armbands. Vibrotactile arrays are particularly appealing since designers can vary parameters including cue location and duration to create distinct haptic icons and represent a wide range of information. To truly accomplish this, individuals must not only learn the mappings, but also reliably perceive the cues themselves. Reliable perception of cues means that individuals should be able to indicate the location of where a cue is felt along their forearm with low error. The goals of this study were first to determine how well people can localize vibrational cues presented on the forearm, and second, determine if cue duration affects localization performance. We had 16 subjects perform a localization task with a custom vibrotactile sleeve, where we presented tactile cues at 3 duration conditions. We also ran a visual condition, which was just used to verify our methods, so the remainder of this video will focus on the tactile task. Our goal was to measure how well people could localize the tactile cues. To characterize precision of subjects' guesses to each target, we computed the mean response location for each unique stimulus. We also evaluated how accurately individuals perceive the cues. In this way, we computed the response variance for each unique stimuli. Each column shows the group level response means for each duration condition. We can visualize where along the response range the mean response to each tactor was perceived. Tactor location had a significant effect on subject response means, where all response means were significantly different from one another, but this was not affected by duration. The next thing we assessed was how the variance in response to each cue varied with respect to tactor location as well as duration of the cue. Again, each column shows the results for each duration condition. Tactor location significantly affected the response variance to the tactile cues. However, this did not differ based on duration. In conclusion, the cue durations tested had no effect on tactile localization performance. The visual task results validated our hardware implementation. Our results support the variation of stimulus duration between 100 and 400 milliseconds for tactile arrays, but the differences in response variance motivates improved design of tactile displays.